Alright guys, so this is the 3.5 retrieval, pages 73 and 74. So first up here, this is the part that will go with your ready. We're looking just at classifying numbers. So first thing we want to look at is if we can simplify what we're given at all. So thinking about the square root of 81. So you might first look and see a square root and think, okay, well that's going to go on forever. It's going to be rational, but we have to remember that the square root of 81 is just equal to 9. Okay, so 9 is not a number that goes on forever. If you weren't sure that the square root of 81 is 9, you could always break down 81 and see what you end up with. Okay, so 9 is definitely a whole number, which also makes it an integer, which makes it a rational number, right? It doesn't go on forever, it stops. And then it is, of course, a real number, right? Anything that doesn't have an I in it is going to be a real number. Next up, 2 over 7. So it's not irrational because it can be represented as a fraction. It doesn't have an I in it, so it's definitely a real number. It's not a whole number. It's not 0, 1, 2, 3, 4, or anything like that. It's also not an integer, right? It's not a positive or negative whole number. It is a rational number, though, because we can represent it as a fraction. All right, next up we have negative 36 over 12. So this is another one of those where it's tempting to say that it can't be a whole number or an integer or anything like that, just like A here, but we can break this down a little bit first. So it's going to remain negative because it started negative, but 36 over 12, we can simplify that. 36 divided by 12 is just 3, so this is just the same thing as negative 3. So because it's a negative, it can't be a whole number, but it's definitely an integer because it's a negative whole number. And all integers we know are rational numbers, right? They have a stopping point. They don't go on forever, which means it can't be irrational, but it's definitely a real number because there's no imaginary part. There's no I in this number. All right, last one for this type then is the square root of 10. So the square root of 10, there's no number when I multiply by itself, I get 10. So it's definitely going to go on forever. So when it goes on forever, we know it has to be irrational. It can't be rational, can't be an integer, it can't be a whole number. But there is no I in there, so it definitely is still a real number as well. All right, so that concludes what you'll need to work on the ready portion. Okay, so the ready looks just like this. You're looking at the number, classifying. So some of these you need to simplify first. Like the square root of 625, for example, is one you'll need to simplify. Some of the other square roots, fractions, see if they can be simplified at all before you decide what category they fall into. All right, so page 74 then, so the second part of the retrieval, so this will help you with the goal part of your lesson. So we're going to solve by factoring, algebraically, or by graphing. So looking at this first one, I see I have x squared, x, and a constant. So this is my hint that I want to check and see if I can solve by factoring. So for solving by factoring, I need to look at a times c. In this case, a is 5, c is 6, so a times c is 30. And then I want to think about my factors of 30. So there's 1 and 30, 2 and 15, 3 and 10. 5 and 6, and that would be it. So I'm listing them all here because we are trying to find a pair that when added together gives us this 2x. So as I'm looking though, none of them are going to combine to give me a 2. So that means this one is not factorable, which isn't a big deal. We'll just go about solving another way. So algebraically, we can do this algebraically if we use the quadratic formula. So again, for the quadratic formula, we have to determine what a, b, and c are. So here's a would be 5, b would be 2, and c would be 6. All right, so then I'm just going to follow that quadratic formula. So x is opposite of b, plus or minus the square root of b squared. So b is 2, so b squared is 4, minus 4 times a, which is 5, times c, which is 6, all over 2a. Now in this case, a is 5. All right, so from there we just have to start simplifying. So negative 2 is just going to come down for now, plus or minus the square root of 4 minus, let's look at 4 times 5 times 6. I know 5 times 6 is 30. 30 times 4 is 120. All over on bottom, 2 times 5 is 10. All right, so we'll keep going along here. So I'm going to go under that square root still, and I can simplify. 4 minus 120 is going to be negative 116. Okay, so I can tell I've got a negative under the square root. I'm going to need an I. And this is really the part that we need to simplify here. So I know there's going to be an I, but I want to see what can I do with 116. Does that break down at all? So thinking about 116, I know that's even, so it's got to be 2 and something. So it's going to be 2 and 58. And then keep breaking down. I know it's even still, so it's got to be 2 and something, 2 and 29. And then 29 is a prime number, so that one does not break down anymore. So 116 would be 2 times 29. So I can get that 2 out of there, but the 29 will stay in. So if we bring that back over here, we have negative 2 plus or minus. I brought out a 2. The negative gives me an I under the square root. And that 29 was left inside. All over 10. All right, and the last thing to do is to see if this number that's on bottom, so in this case it's a 10, can simplify what we're looking at all. So I want to think about splitting this into 2 fractions. So I take my first piece, which is the negative 2, plus or minus my second piece, which is also over 10. And then I can simplify this a little bit. So 2 over 5 is the same as 1/5, so that does simplify a bit. Plus or minus. This 2 over 5 is also 1/5, so on top we just have I square root of 29. Right, we can have a 1 there, but saying 1 times that doesn't really change it, so we don't need the 1. All right, so that's as much as we can simplify that one. Okay, looking at the next one here. So this is where I have my A and my C. This one has no B. It has no just X piece in the middle. So when that happens, we solve algebraically by getting X squared alone initially. So in this one, to get X squared alone, I'm going to subtract 75 from each side. And so here they cancel, and we get X squared equals negative 75. All right, then I can take the square root of each side to get X alone. So X equals plus or minus the square root of negative 75, which we have some work to do with here. So there's a negative, so there's definitely going to be an I, and I want to see if I can break down 75 at all. So I know 75 is 3 times 25, and 25 is 5 times 5. So if we think about that, we'd have 3 times 5 times 5. I know I need a pair of something to bring them out. I've got a pair of 5s here, so that'll come out. So this would be plus or minus. The 5 comes out. Because the negative, I can bring out that I. Square root of the 3 stays inside from over here. All right, so we broke down the square root as much as we can, so this one would be completely simplified.